I will talk today regarding one of the biggest challenges in Bitcoin mining world, how to get rid of all of that heat generated by equipment. Because this equipment, of course, it's still microprocessors, chips, but in very high density setup. It means it generates much more heat than ordinary computers. With normal data centers, of course, you can use air conditioners to cool down air, to allow chips to work at acceptable temperatures. But these kind of machines, and here's a good example, it's designed with special ASIC chip, and we have hundreds of ASIC chips inside of that small machines. It means it can replace heat of hundreds of normal servers. So if we will put a lot of air conditioners into such a mining farm or big data center for producing Bitcoins, we will consume even more energy than these Bitcoin mining machines is consuming. It means it just not make sense to mine anymore because price of the electricity in total will be too high. So then question arises, so how to get rid of all of that heat? And of course, most popular solution is just to use ambient air, and this is how it looks. It's most popular mining farm. So generally we are using ambient air to flow through all of these chips. We take it from outside and try to cool it down. Of course, normal temperature of these chips is limited to some realistic number. Usually it's like 85 degrees. So it's a matter of efficiency of that cooling system of this. So if it's hot outside, for example, you are running this mining equipment in a hot climate and you have like 30 degrees air temperature, it's really hard to use that technology to cool all of these chips. Also, there are a lot of other negative sides of this kind of technology, because just imagine if there's a rain, you have to protect all of this equipment from humidity. If it's humid climate and you have to switch off this equipment temporarily, sometimes it happens due to requirements from the energy supplier or due to some failure, it can be covered with water very quickly, and it can also break such equipment. We have to protect it from the dust which comes from the air. And of course you have to invest into additional huge ventilation system to provide that air with significant flow and get rid of all of it. It's still most simple solution to run these mining farms, but all these negative sides and makes it not very efficient really. So we started to think how to improve efficiency of the cooling and in the same time maybe gain some additional benefits, and I will tell about that. So, and just basic information from the school, just to understand you, to let you understand the difference between volume. This is in a scale you can compare 1 kilogram of the air and some dielectric liquid and water. You can see dielectric liquid is a little bit larger than water, but still it's not on the same level as air. So of course, liquid heat transfer elements are much smaller in size than air. It just means if we will switch somehow to that liquid coolants, it means we can use much less volume of that thing. And the next page is specific heat compression. So it shows how efficient air comparing to water or some dielectric coolant like oil in terms of cooling. So we need to flow much more air in volume just to get rid of the heat than water or liquid. And it's several times difference, of course, many times difference. And here another chart is because on the previous page I shown you how much air do we need to flow at 20 degrees and 1 atmosphere of atmospheric pressure to get rid of 1 kilojoule of energy. And here, what it means, 1 kilojoule of energy. 1 kilojoule of energy is, we can use it to heat that very small cup of coffee. So it's very, very tiny amount of energy. And you can imagine, these modern mining farms are generating millions and hundreds of millions of kilojoules of that energy. So if looking to that page, how much air do we need to pass through all of that equipment, you can imagine the scale of these fans and pressure and everything what we need to get rid of all of that heat. And again, it's a big question, what is ambient temperature is outside. If it's high, we need to push even more air to cool it down. And this graph shows heat transferability. So you can see air is a very low number and water is one of the best heat transfers substances in this world. And it's huge difference. And oil or different kind of dielectric liquids are somewhere in the middle. But it's still very huge difference between air and oil. We will talk about what's the difference between oil and water in terms of electricity for the next pages, but I just wanted to understand what still liquid substances is much, much better for cooling effect of the equipment than air. It's not on the same level. So now I wanted to explain what are modern types of cooling except of the air exist in the world currently. It's, of course, there are much more, but I will tell about most popular ones. One of the popular one is so-called cooling blocks. So you can see this circuit board on the right photo. It's the same circuit board what we can usually find in such a mining equipment. So if we can put that aluminum heat water block on top of the chip and pass water through it. Since water takes heat much better than air, usually it takes much less volume of the water to get rid of all of that heat. Of course, it works much better than air, but still with a lot of issues on a large scale implementation. Left page shows you heat distribution inside of this water block. What happens inside? You can see temperatures on the left side, so you can understand what is going on inside. Of course, once water passes inside of this water block, it starts to heat up. And once it's heat up, it changes its temperature. It's really not possible to make this water block to be cooled absolutely equally in all places, because water just needs some time to flow. And since size of these internal pipes are also very small, you cannot make huge flow because you will have to create fantastic pressure for all of this water. It means what chips in different parts of this hashboard will just have different temperature in the end. And in terms of working abilities of the miners, very, very important task is to make all these chips working at the same temperature, so they're same efficient. Because construction of the mining board is made in the way what chips are connected in series. So if one chip fails, it means half of the board or even total board will start to fail and it will not work. So this technology is better than air, but of course it's much more expensive. You have to machine or produce all of these cooling blocks. But if you can think even further, you can see these pipes with water, and water is electricity conductive. So in case of some leak, that water can fall to electrical circuit board. It will be short circuit, so it will damage equipment immediately. And imagine, like on the first page I shown you, we have a farm with so many miners. If you will connect all of them in a single chain of water distribution, even we will have one small leak, it can stop the whole mining operation and damage equipment. So it's a lot of issues how to build it in a proper way, in a cost efficient and very reliable. And also these temperature issues, it's not resolved with this kind of technology. So we experimented a lot with that kind of cooling, but then decided to switch our resources and time into different kind of approach. So the next very popular method of cooling is so-called two-phase cooling. What it means? That equipment is poured into the special dielectric liquid. It's dielectric, so it works perfectly right below the level of the wet liquid, and that liquid boils at a lower temperature. So once it boils, of course, it's very efficient because it changes the phase from liquid form to gas form. And that process takes a lot of heat from the chips. So potentially this is the most advanced cooling system exists in the world currently. But implementation of that system is still very, very much complicated. Just imagine, that special liquid is a chemistry. It's not like a water. Of course, it's very expensive. And it boils at low temperature. It means it evaporates very quickly. So this system should be completely enclosed. If there is even very small, tiny hole, after 1 day or 1 week, that liquid will just disappear and you will have to add on a daily basis. Of course, if it boils at low temperature, you need to convert it back from gas form to liquid form. And for that, you need to have a condenser. And since it takes heat from the chip and boils, for example, at 40 degrees, to convert it back with condenser temperature of that condenser should be below 40 degrees. And just imagine you have 30 degrees outside, so it will not be possible to use it in a natural way. You will have to pay additional electricity into air conditioner just to make condensation temperature much lower. Another problem with that thing is it's really poisonless. So this liquid usually contains phthor, and in combination with direct sun, ultraviolet radiation, it emits that very poisonless chemistry, and if you will just breathe, you can die, especially if you are working in an enclosed space, and this is how it should be constructed to avoid vaporization of that liquid. So it's really dangerous for the people to work with that for the maintenance purposes. I still think it's the future of the cooling because it's so much efficient, but at this moment several companies try to do some large data centers using that technology, but price of that technology is not allowing to make it on a mass market, and complexity, and always some troubles happens and you have to replace all of that liquid. We experimented a lot, and then we decided, okay, let's think further, and maybe we can find some even better solution than this in terms of efficiency and cost and performance. So when we switched our resources into development of the single-phase immersion cooling system, this is well-known system, and Christian from Brian's also mentioned about that. It's well-known. But of course, as usually happens, devil is hiding in details. So a lot of enthusiasts are playing with this. Of course, it works, but if you want to run it in a large scale, it needs to be developed very, very well. And this is what we did during last 5 years approximately, and I think we achieved fantastic results, and I will show you later about all the use cases. But just in general, I think you understand what's going on here. You just put that equipment into the dielectric liquid. It could be oil, or of course you can choose the best one. It's different kinds of oils available on the market with different properties and of course different price. But generally it's safe for the equipment, and you are allowing that flow, the liquid goes through the chips, takes heat, and then you can just route all of that liquid to the external cooling system and cool it down. So generally, from the first sight, it has the same negative sides as a system with water blocks, because you have to cool all of that liquid with external cooling system, and if there is a high ambient temperature on the street, it will be really hard to do it. With water blocks, you have to keep temperature of the water or liquid inside of the water was pretty low, because you need to create as big temperature difference between chips and that coolant as possible, just to cool chips in the best way. But what we did with this system, we was able to pass that limit and raise temperature of the liquid to unbelievable rates, I would say it like that. And it opens up completely new opportunities to use this system in different kind of approaches. But I will tell about that for the next pages. So let's think in general, what kind of mining system would be just the best on the market? So it should be, of course, cheap. So infrastructure, what you are creating to hold all of these miners, should be as cheap as possible, because in mining business, it's most important how fast you will get a return of your investments. And of course, if you can put a lot of mining machines into the small volume, it means it will just cost less, because it just means what it's most dense system. So we are looking for the most dense system for this kind of setup. So another topic is efficiency of the cooling system. Of course, as I mentioned before, we have to spend a lot of electricity into the cooling, and the less electricity we are spending, it just means it's more efficient. It means we are paying less for the electricity, and in case of mining, it's another critical component, because the cheapest electricity is, the more money you can generate out of it. So we need most efficient cooling system available, and of course we should look at the price of that cooling system. So another important topic is how fast you can produce all of that infrastructure, because in mining it's very important. Once you will get access to the hardware, you want to run it as soon as possible, just to create money out of that equipment. So it should be easy to produce, easy to deliver everywhere in the world, and easy to run. Comparing to the first system what I shown you, in case of air cooling, you have to create all of that infrastructure in advance and prepare to accept all of these miners. It just takes time. But just imagine what you can produce, so-called industrial miner, which is not requiring any infrastructure. You can deliver it anywhere in the world, just plug it into the existing grid or whatever energy supply. So it would be good to have such an industrial modular solution without necessity of pre-creation of any infrastructure. So another very important topic, we know what we have Earth and different kind of climates, and it can be cold, it can be hot, and especially once we know what usually renewable are built in a very hot regions, because there is a lot of sun, but it means also that there is a very high temperature. It's really hard to run mining equipment when it's very hot, because it's hard to cool all of that equipment. I already explained it before. So if we will have a system what allows to run all of that equipment in very high temperature regions, and we have up to like 50 degrees in Arab Emirates, for example, in very hot days, it would be very, very beneficial, of course. And another important topic, what Christian from Bryans also covered in the previous speech, what we can run all of this equipment in different modes. Generally, it's defined by the chip designer, what is optimal working conditions for the chips, but we can always overcome all of these conditions and run it at custom conditions. And there is a process so-called overclocking, but generally it means we just taking more power, more production from the chips by putting a little bit more power into the chip and raising frequency. And this is very important. If you can take heat from the chip, you can run all of these chips at almost double capacity of the production. What it means for the investor is very important. You can just pay twice less, or you can pay the same but get double hash power. So with proper cooling, if you can get rid of all of that heat generated by the chips, it makes it possible. So it's a very important feature. And of course, another important topic, how reliable this system is, how safe, how ecologically friendly, and so on. So we can get permission to run it from any government, from any place of the world, and how safe it is for the people who are working with it. And we will talk also about fantastic additional features what we can potentially get from this kind of setup. So it's just a summary, just a guess what we would want from the best mining system in the world. And then I want to explain you how we actually accomplished all of these topics with setup what we created, and even much more. So the first topic was density. So on the left screen you can see a lot of flats. It's just a simple example. Usually one flat consumes like 5 to 8 kilowatts of the power. It's a limitation. People think that we don't need more. You have some coffee machine, you have jacuzzi sometimes, but 8 kilowatts is enough. So if you can imagine what one system on the right side consumes the same amount of energy, consumes, it means it can generate bitcoins as a 1,000 normal flats on the same level. So it means at the same power consumption as this part of the city. So 1,000, so it means 8,000 kilowatts we can push into that 40 feet container inside with completely self-sustainable cooling system which is placed around that container. So it can be just ran, plugged in, and consume and generate bitcoins at the same level as 1,000 normal flats or houses or whatever. So I never heard what anyone in the world did anything like that. So just imagine 8 megawatts, like a city inside of one 40 feet container. So we accomplished that. We did a really good job, and it worked. And I just wanted to explain how we did it briefly, and explain what is behind of all of the technology, so you can better understand how it's possible to reach that level of density. So on this screen you can see typical hash board. We can find it in this miner. It's a circuit board with a lot of ASIC chips on it. Each ASIC chip is pretty small. It's only 18 square millimeter, but it emits a lot of heat because it's specially designed. And to get rid of all of that heat, usually there are heat sinks which are placed on both sides of the hash board. And of course, in case of air cooling machine like this one, air blows through all of these ribs of the heat sinks and take that heat out of the chips. But what we did and what we researched, we figured out what the length of these ribs is actually doesn't work. So it only works for the first 5 millimeters only. And then efficiency of the cooling drops significantly, and after like 2 centimeters is almost zero. But if you will pass not air but some liquid inside of these ribs, you can take this heat in a much more efficient way than air. And in this case, you can lower it even higher. So in our high density setup, what we did, we put much more chips on the hash board, and we lowered ribs of all of these heat sink to only 4 millimeters height. And it allows us just to put inside of a limited volume of the container much more of such a specific hash boards and just much more chips. Of course, this heat sink was designed in a very special way. It's not just ordinary ribs, it's just with a lot of IP around it. But in general, we was able to lower dimensions significantly of all of this equipment just to make it much, much more compact. And here I can show you cooling system abilities. You saw on that picture what we have cooling system around the container. It's specially designed cooling towers. They just takes that liquid out of the container and cools it in a natural way with fans on top of it. And capabilities of that cooling system is represented on that left graph. From right picture, you can see actual information from one of the running containers. And this is specially designed miners, but just half of it. So we can see 3.77 total power. It's in megawatts. And cooling system fans, you can see 50% only. It was 45 degrees ambient temperature outside. It means we can put just double amount of miners. It was first revision of the miners. We have several next revision of the miners with double capacity, and it just confirms what we can cool at least 8 megawatts with that cooling system around the container at 45 degrees ambient temperature outside. This graph just represents, we can go up to 50 degrees ambient. Of course, efficiency of the cooling system drops a bit, but it's a very rare conditions when we have such a temperature in most hot regions on this planet. And in this case, we can just reduce overclocking, for example. But in most of the cases, 30, 45, 40 degrees, we're at the level of 6.5 megawatts of the cooling capacity of this container. So another very interesting story, what we can replace all of this cooling system with heat exchanger, and in case if there's a water supply next to the container, like small lake or river or whatever, we can just take that liquid from the lake and use it for the cooling purposes. Of course, it's very beneficial because comparing to, by the way, I forgot to notice, these miners generates a lot of noise because they have very small fans and they are rotating in very high speed. So generally, it's not possible to even walk in an air-cooled farm. You have to protect your ears. In our system, with that big fence around the container, it's much, much more silent. So it's an incomparable. You can normally normally talk just next to these cooling towers. And of course, it depends on the ambient temperature. It's also changed rotation speed automatically. When it's cold, it's completely silent. When it's very hot, you can normally barely walk around it. But if you can get rid of all of that cooling system completely by using external water supply, you will have completely silent system. And I will explain you later what fantastic benefits it actually opens up. So important thing to notice, we are not consuming any water here. It's recirculation of the water from the water supply. And heating of the water is insignificant, only a couple of degrees. So it means it's very ecologically friendly. And since there's a huge area of the lake, it cools down in a natural way. So we're just using nature to cool down all of this amount of the electricity in a very efficient way. So now I wanted to talk about most critical inventions what we did to accomplish that project. So on the left side, you can see typical air-cooled miner. Air passes through, for example, it's 30 degrees outside and it's heated up to 60 degrees. On the right side, you can see specially designed miner for the liquid cooling. And the biggest difference what you can see here is what liquid enters that miner at 60 degrees already and outputs in 65 only. So it means we can work at very, very high temperatures of the liquid. And this explains how our cooling system is so much capable, because it will be a huge difference in temperatures between liquid target, in this case it's 60 degrees, and even in a most hot day air outside, it will be probably 45 or 50. So we have 15 degrees difference, and this difference is enough to cool that liquid from 65 to 60. This is why our system is so much capable. And on the right page, you can see just in a scale comparison of volume of the miner. So we have like 6 ordinary air-cooled miner by the same power consumption as specially designed liquid-cooled miner. So this is why we can put so many miners inside of one container and get that crazy amount of computing power. And of course, it's important to say once we are cooling it down in a very efficient way, we can overclock it and generally get double power consumption. In case if market allows, if electricity price is good, if Bitcoin price is going up, we are flexible here with adjustments of overclocking of all of these miners. So this is the actual unit on left side, what we created, and it's working. And this is some of our handsome guys who was involved in the production of all of these technologies and heat sinks. Yeah, so this is a heat map. So very important what I noticed, especially for water blocks cooling, what it's very, very important to cool all miners and chips in a very equal way. So we are working at a constant temperature, all of them, and especially chips on the hash boards and miners itself. And this is another invention what we did, and even got a couple of patents for that, because you can see a lot of miners. This is a representation of the miners inside of the container, and maybe you see the temperature difference between it's only like 1 degree, sometimes it's 2 degrees for selected miners. So it was really hard to accomplish, because you have huge tank with you know, a lot of issues with flow, and flow is very huge also, and to cool it down in a very equal way, it's really hard to accomplish. This is why I told you what a lot of enthusiasts experimented with this kind of technology. Of course, it works at a small scale, but if you go to industrial scale, it's completely different story. You have to invest a lot of time and research into making it really right, reliable, and working. So this is one of the examples of overclocking. We work together with Brains, and this is a shelf miner, S19 Pro, and just to show you example of the efficiency of the cooling system, what we created, you can see on the right top screen 191 terahashes. Usually this miner is producing only 110 terahashes, so it's almost double hash power what we was able to squeeze out. And temperature of the chips, you can see it's still 80 degrees, so it's very cold. Unfortunately, this screenshot is not very good quality, but you can see the data. So it's optimal temperature for the chips. It's almost double hash power, and the only way how it could work is with liquid cooling, with proper flow, with proper everything. But of course, this miner originally was not designed for this liquid cooling, so we just used it and put it into our system. In case of our custom miners, what we can design from scratch, we specially designed heat sinks, chip distribution on the hashboard. It's even much better results. So we tested more than double production of the hash rate with a single chip. So we can squeeze out double hash rate from the single individual chip with keeping temperature of these chips at the acceptable level. So it's very important feature of this kind of setup. So this is actual running operation of our containers. You see how it works. So it's real. It is working. This unit is 2.5 megawatts. One of our first revisions. It was filled with S19 Pro miners. When we changed to our properly designed miners and reached that incredible level of 4 and more megawatts per container. This is a place in Texas with a lot of containers running with different kind of miners and setup. So let's talk about safety. It was one of the topics when we thought about the best system in the world. Of course, it's very important to make the system completely safe, since it holds a lot of different technologies and liquid. We need to think in advance what influence it could be, it could give to nature and so on. So one of the biggest disadvantages of the air-cooled farms is the access of the water or humidity from the air. And here this problem is completely eliminated, because container is completely closed. And inside, air is not coming inside at all. We have small air conditioner on top of the container just to dry air inside, just to keep it at the constant temperature so electrical equipment is safe. So this setup doesn't care about any conditions where it was installed. It can be under rain, it can be very humid air, very hot or very cold, it doesn't care. So it's one of the biggest benefits of using this technology in front of other technologies. So another point, so since all of this equipment is below the level of the liquid, it doesn't contain any rotational parts like fans. With ordinary air-cooled farms, all of these fails, and imagine if you have thousands of units, it means what like team of the people should walk every day and replace all of these not working fans because it just fails. And in our case, we have no parts that can potentially break, and temperature of the liquid stays all the same at the same level, at the same temperature, because we can adjust it with external cooling system accordingly. What it means? It means hardware will be at much more reliable state, because thermal expansion of the circuit board is not exist anymore. This is one of the reasons of failure of the miners. We have no rotational parts, no fans. So once it starts, it just works. We don't have to usually replace it. The only critical component is the power supply. If we are overclocking very high, sometimes it can fail. But if we will design our own miner and put proper power supply, it will just work without any issues. Oil. People think that oil is really dangerous. Of course, it can burn, but there are a number of oils available on the market currently, and of course, we can choose the best one with very high flash point. But since our container is completely enclosed, there is no access of the oxygen inside. So even in case of short circuit, for example, some cable will start to burn. That oil will never burn. Of course, we have alarm and fire extinguisher system that can trigger immediately and switch off the container. But even if nothing of it would work and there's open fire, that fire will just die by itself, because there's no oxygen to support that fire. Another topic, of course, that container holds a lot of oil, and there are some connection points, valves, something could happen and that oil could leak. We have a system that stops pumps and container operation once leak is detected, but even if it happens, we can easily get rid of all of that oil into a special tank, because oil is not mixable with water. So we can integrate a simple separator. Usually you can find such a separator at any car service, for example, because we are replacing oil all the time within a city. So we have special drainages in a floor to collect all of that oil. And this what can be done also for and integrated to the parts for the containers. So in case if there's a rain, with that separator, water will be separated and goes to the ground. In case there's a leak of the oil, it will be collected in a special tank what can be hidden below the ground level. So this problem is easily solvable, and no nature will be hurt. Another very important feature of this system is, of course, noise levels. And this enables actually one of the biggest advantages of this system. We can run it everywhere in the world, even in a city center, even in a nature with animals around it. Normal air-cooled farms are generating so much noise, but this container is much more quiet. And like I mentioned before, if we will use and recirculate water from some water storage, it will be completely silent. So now, most interesting topic, what I want to cover. So once we designed all of that system, of course, it's very efficient in terms of mining. It can overclock chips, it can run at very high ambient temperatures, it can be fast produced at the factory and delivered everywhere in the world. So we resolved all of these issues, but then we thought, okay, what additional benefits we can get from that system. And Christian also mentioned about some use cases. And here we have fantastic use cases, because comparing, for example, to water blocks, since cooling efficiency of the water blocks is low, we have to keep temperature of the coolant or water at pretty low numbers, like 35 or 40 degrees. And for most of the heat consumers, it's just not enough. And here we can raise with heat exchanger temperature of the water up to 60 degrees, even 65 degrees. This is what we tested. And it opens up huge market for the utilization of that heat. We can provide it to the greenhouses, we can provide it to the private homes, to chemical industry, to whatever. So we can replace old school heating stations within a city who are still burning like gas or diesel with industrial heating stations and just provide heat for free. Of course, we want to have discount for the electricity, but this is what we should agree with government. It's win-win situation for everybody. We can give in exchange heat at 50% discount, for example, and get also discount for the electricity to make miner happy. Of course, this system can be designed in a small form factor, like you can see on the right top screen, and just use it in any private house potentially. And if you are spending a lot of energy into heating, this is a good solution for this kind of use cases. So that high temperature of the water, what we can get potentially while transferring that heat from liquid to water using some heat exchanger, opens up unbelievable possibilities for providing all of this heat to different kind of consumers. So this is a smart heater prototype. We designed it in a small scale, and we are going to run it here in Lugano at one of the places very soon. So if anyone is interested, you are welcome. Maybe in 1 month it will be working, and shown one of the use cases how we can benefit from mining of Bitcoin and providing heat at the same time. So another very interesting topic what we opened up once we started to use this kind of technology is a energy stabilization market and energy, and using Bitcoin as a energy transmission. Just imagine if we have several sites, one site with a lot of area where we can build potentially solar panels by ourselves and just feed containers next to the solar panels. So it will be very efficient to mine Bitcoins in that place. And then we have another place where electricity price is very expensive, like in a city center currently. How we can help ourselves just to pay these bills for the electricity? We will just use Bitcoin to finance expensive electricity in our another facility. So we don't need to create any grids or transmission lines anymore. It makes this liquid cooling solution like a accelerating of decentralized energy production. So we can find whatever places in the world where it makes sense to create renewable infrastructure, because usually renewable is just providing cheapest electricity. We creating a site, getting Bitcoins, and helping to finance and resolving our issues with expensive electricity supply in other regions. So it just means what Bitcoin helps to produce more and more renewable power plants, because usually it was considered if you're investing into renewable, you will get ROI at least in 10 or 20 years, because it's really hard to sell all of that electricity to the market immediately at 100%. And of course, price of the solar panels and wind generators are pretty high. But in combination with Bitcoin mining containers, we can convince investor to invest into that system and make profit very much sooner. So generally, if there's a market conditions for Bitcoin are good, we did some estimation, we can get ROI for this kind of setup in 2 years. And it just accelerates creation of the renewable power plants everywhere in the world. So if you have a land, if you have agreement, if you have money to invest, just do it and use all of it Bitcoin to compensate price of the infrastructure. And then once you will get ROI, it means you are converting yourself from Bitcoin miner to energy producer. So you don't care what will happen with Bitcoin any longer. You can always use all of that energy to sell it to the market, sell to the grid, change equipment to AI, do whatever. So you will have very valuable resource in your hands after all. But of course you will want to continue mining because it just makes sense. And another story is energy stabilization. You know, once new power plants appear on the market, of course, especially for renewable, they are generating electricity in a not equal way. So, for example, solar panels are generating only in the daytime. It depends on the solar activity. Wind depends on the wind. And once you will connect a lot of different kind of power sources into the single grid, this is where problem occurs. Sometimes these grids start to overload. It can lead to blackouts on the governmental level, or even within a country. And this is where our containers can help to resolve this problem very easily, because you can see it on the graph. This is energy generation with different kind of power sources. We can follow consumption of our containers exactly to compensate with energy generation, because we can adjust overclocking, we can switch on, switch off within a seconds and just follow the target very precisely. And this is one of the also benefits of the single phase cooling system what we designed, because it's not possible with air cooling solution. Chips are not allowing to change power consumption so quickly usually. They have to be preheated. So they have to stay at pretty high temperature all the time. And this is what we can provide with our cooling system. Of course, if we will have to switch off the equipment, we can still have liquid at some certain point heated. We can keep one miner working, for example, we can switch off cooling system, so liquid will stay constantly at high temperature, allowing all of this mining equipment change power consumption within a seconds. And this is a very, very important, as we learned, because this kind of energy generation actually requires this kind of setup. You have to react within a second just to allow that stabilization on a certain level. So all of that means that if you want to invest into the battery storage, for example, it doesn't make sense anymore. You better invest into the mining container. You will do stabilization. You will get 100% of the electricity all the time from the grid, and then sell Bitcoins, just like you are selling electricity from the battery later. And cost of this setup is just much cheaper than investing into the battery. It's much more reliable because, as you know, battery have limited number of cycles, and if you are doing charging and discharging every day, for example, it will not last more than 1 or 2 years at most, even for most productive and best batteries in the world. So this is fantastic opportunity to explain to the governments, because this is what networks and grids are suffering at this moment globally, everywhere in the world, due to uneven energy production and consumption. With the blackouts, with the huge problems, investors couldn't sell a lot of electricity from the newly, freshly built power plants, because grid just couldn't take it. And if we will put all of these mining containers just in the proper places next to the energy production, we can stabilize this market. In the same time, if prioritized consumers will want our energy, we can just follow the target and give away all of that energy if it's needed for the city or for the people or whatever. So investor is happy, government is happy, miner is happy, because he's getting rewards in exchange of that feature. This is what we tested in Texas, because we are a bit more advanced than in Europe. We're definitely offering significant discounts for the electricity if you are applying to these programs, but it should come also everywhere in the world, because it just makes sense. That's it. So, thank you. So I just want to say what we are developing, and of course not just we, other people also. It just helps people in the world to understand what Bitcoin is not evil. Bitcoin actually helps to accelerate progress in different kind of industries. It can resolve a lot of different kind of issues, just like Christian from Brains mentioned, and I'm just confirming. More and more use cases will appear next month and next years, and people will realize that this is a good solution to resolve. For example, it can resolve heat issue with cold countries. We can put all of this mining equipment into the North Pole and provide heat to the greenhouses and start making and growing oranges right on the North Pole. We can make decentralization of energy production. We can get rid of all of these expensive grids that are overloading. We can resolve a number of issues, and you will see it's just the beginning of the new era. Thank you. So if you questions, okay.
1, 2, 3.
Yeah, it works.
So only thing I'm missing here is artificial intelligence. So artificial intelligence part here.
Yeah,
so I'm guessing you're talking about immersion cooling.
Right. This is what I mentioned. Just imagine at some certain point we all understand what artificial intelligence is just growing in the world. I think in the future people will not be even allowed to drive personal cars. So it will be under control of the computers. It just means what data centers, what holds not just Bitcoin mining equipment, but special equipment for artificial intelligence, this market will grow exponentially. This technology, what we developed, is completely universal. It can provide cooling system, very efficient one, to any kind of circuit boards, any kind of processors. So once you will create this infrastructure everywhere in the world, you can start from Bitcoin mining because it just makes sense. It will help you to finance that project. It will help you to create money, create profit, but also create renewable power plants. So you can be profitable while creating stuff. And then at some point, if it makes sense to just change the equipment to artificial equipment, you just do it. And infrastructure is ready, you put new equipment and participate in the global world progress.
I was wondering, maybe you found a magic way how to use ASICs for AI.
ASIC is a very special thing, yes. Christian explained it before, it just do very dumb calculation, can be used only for Bitcoin mining. But infrastructure, this is what matters. Infrastructure and energy production. Once you have both in your hands, you are ruling the world.
Yeah, I had another question, maybe a bit more technical. I've seen in the previous picture that you placed in Texas all the minings near a primary substation, right? Was that a conversion station, this one, so you can get direct electricity from the grid?
Yes, exactly.
Okay, and if you do these kind of things in the city center, you're going to place maybe a smaller unit near a secondary substation, right?
Absolutely. This is what we're actually doing right now in Lugano. We got very interesting requests from one of the famous restaurants who are working here. Yeah, they have several buildings, and one of the buildings is pretty huge, so we can put solar panels on top of it, but another buildings are much smaller in a city center. So we wanted to utilize heat for cooking in that building, so it's a very good use case for our technology. We want to create Bitcoins in a cheap way using solar panels and then help to finance expensive electricity in a city center. So this system allows to run it in a city center because it's just silent, it's safe, it can be designed and produced in any scale, any kind of power production.
Yeah, but my question was like, you say that these rigs can follow like the energy consumption. They can adjust their energy consumption, right? So it means that you have to collaborate with a distribution system operator or a transmission system operator because it's a kind of demand response algorithm, right?
Absolutely.
When the TSO tells you, okay, you have to adjust your consumption, and then you do it.
Yeah.
So, and I think this is very challenging according to the different parts of the world, because like in Italy, there are not some kind of programs to do this, but maybe in Texas it's different, and the TSO provides you this kind of informations.
Yes, in Texas it is working because we are the organization ERCOT, so this program is already within a years, but we just started using it at a large scale because nobody was able to build such a system before, just to follow target in a very precise way. So we implemented that system, it works, but you are wrong what it's not working in Europe. We have this system ready, so we had some discussions, it's just not regulated by the government. We can easily get information about loads of the grids from different places. We just need to have a permission and agreement on the governmental level just to start doing it. All the infrastructure is already created. But in case if you are using your proprietary solar panels, what you are creating yourself, of course, it's under your personal control, always.
Yeah, okay, thank you.
I think it will come, but to answer your question, it will come very soon. People will just realize what it just makes a lot of sense.
No, because even with our smart meter, we cannot have our energy consumption in real time if we want.
You have smart meters at the power plant anyway, not in your private house, but on a larger scale. You have all of this equipment, and there are companies who are also thinking in this field, and they are offering these kind of services just to add additional current meters and so on, just to create monitoring system to see where grids are overloaded, where we can put a bit more energy, where it makes sense. So, of course, it's in a development currently.
Thank you.
I would like to add something to what he said. Actually, in Italy, there is a pilot project which is called UVAM that allows you to use consumption units to provide flexibility to the grid. However, my doubt is related to the market incentive that may be linked to the actual feasibility and business model of the mining operation facilities to provide flexibility to the grid. I was wondering if is there any kind of incentive right now to provide flexibility, and maybe there is more marginal utility for the facility in continuing consuming energy and not maybe downgrade the consumption to provide the service. Because actually you have by now in Europe you have the limit of purchasing back the energy with €0 per megawatt hour. So until we don't have any kind of negative price in the electricity market, maybe there is no market incentive for this kind of business model. So I think that it's not a matter of feasibility from a technical point of view, but maybe from a market design point of view. So that's my doubt.
For Bitcoin miner, it makes totally sense to get electricity for free, right? If there's electricity with zero price, we just want to get it as soon as possible.
But it's not a matter of acquiring energy. It's a matter of sell it back to the grid, right?
We don't want to sell it back to the grid if we can mine and generate Bitcoin for that kind of electricity. This is the answer. So you know what is going on in Europe? Government is subsidizing creation of the renewable solar panels on top of your roofs. Of course, they are helping you with investment, but in exchange, you're obliged to sell electricity to the grid at a very cheap price. What we are offering here to all of the people, you better get credit in a bank and not be obliged to sell electricity and just mine for yourself. You will get ROI much sooner with all of that Bitcoin what you can create. And then just like a showcase what I just explained with that restaurant, if you have to pay expensive price for the electricity because you have just no other way, that transfer of the energy using Bitcoin can resolve that issue and can save a lot of businesses.
I was wondering what incentivizes you in order to turn off miners when there is a high demand from the city? And the second question is, have you considered to use artificial intelligence in order to forecast when there is the right moment to turn off or turn on your miners?
Yes, absolutely, and very good question. So it's not a device for turn off and turn on, it's just software implementation. And I think we will work with Brains regarding that. They already helped us with special firmware for shelf miners. But since we are using our custom miners, it just makes much sense to create everything from scratch. So it's a software and firmware. And the help of liquid cooling solution here is very significant because, like I explained, we have to keep chips at certain temperature all the time just to allow them to work in this mode. If with air cooling solution, it will not work because once you switch off the miner, it cools down immediately, and then it just takes time to heat up again and turn on again. And to answer your question regarding using artificial intelligence, yes, it makes totally sense because we have so many chips, so many miners in a large farm. All of them can work a bit differently because chips are just coming different from the foundry. They're a bit differently produced. So we can get all of this big data regarding working operation and then adjust settings of each individual miner and each individual chips. So it makes sense. It's in development. So let's see. For huge farms, it's very beneficial. Even if you squeeze out like 2% more of the efficiency, it's huge additional profit.
I would like to connect to their question. They talk about regulation, but I would like to know if it's necessary to have a regulation if we use this container, I would say, as a standalone heating generation. If we divide this huge amount of heating generation in order to sustain single buildings, and we don't connect it to the grid. At the moment, for example, I'm in Thailand, so in Italy there is the possibility to install solar panel out of grid with a very small regulation, so it's easy. Is it possible to do the same with this heating system?
Yeah, absolutely. Regulation that just means some safety regulation, ecological regulation, noise regulation, and this is what we resolved, all of that. So nobody will care if you will have that heater in your basement or even outside if it's not disturbing any neighbors.
Yeah. And last question. So in to simplify this this process, is it possible to see this container, this Bitcoin mining process, as just a heating source that is possible to interface with nowadays technologies? So, for example, heating pumps or other solutions?
Yeah, absolutely. It can be integrated all together in one system. Of course, we can use it as backup, or we can use heating pump as backup. For example, in that example again, regarding that restaurant, we are cooking bread, but bread is usually cooked at 200 degrees, and we have only 50 degrees. What we can do, we can just save some energy to preheat to 50 degrees, right? So we are saving like 1/3 of the energy what is used to cook bread. So it's a good combination, of course. We have hot water, so then do whatever you want with it. Just mix, use
maybe
valves, use electronical system with very smart water distribution. You are flexible, just your imagination.
As the heat source, maybe of the geothermal process.
Yeah, absolutely.
Okay.
We can cook spaghetti.
Absolutely, absolutely.
Sous vide steaks, actually.
Yeah.
Water bath is like 46 degrees.
Right in Lugano Lake, if we will connect.
Oh yeah, sorry, exactly. What is the highest temperature that we can reach the heating water?
Yeah, this is what I mentioned. It's 60 degrees.
60 degrees.
Yeah,
okay.
and this is a key factors what differs this technology from any other technology with liquid cooling. It's very high temperature of the liquid or water. We can convert that heat from that dielectric liquid, because we don't want to pass that dielectric liquid to long distances. Just doesn't make sense. It's
Yes,
expensive. Of course, it's much cheaper than two-phase, but still, we can just use heat exchanger. We can lose like 3-5 degrees of the temperature, but still it's enough. And you will have fresh water, just hot water, and utilize it whenever you want.
Hi. I can see all the advantages are pretty clear. Just I want to know if the aspect of the maintenance of the units, because I can imagine, I'm not an expert, but I can imagine that a classical air-cooled miner can be unplugged and extracted from the grid to be, if there is a failure, or to maintain. But when it's in a liquid, how it differs, the maintenance of
Right. It's different, of course. With air cooling miner, you have to. It's much easier. You just unplug it. But the biggest difference is here is what it's always something happens with air cooled miner, and with liquid cooled miners, usually nothing happens because temperature of the liquid stays the same. There is no thermal expansion, no rotating parts. It just works. You know, if you have your personal computer, it can just work. It's just the same. If there is no impact on the changing dimensions and contact is nicely soldered, it just works. So what we learned, maintenance is much less comparing with air cooling units. Of course, sometimes something could happen, but you can just open the lid, remove that particular miner from the liquid, and just do maintenance just like you are doing for air cooling miner. It's not something really complicated.
Good, thank you very much.
Two questions. What about the lifetime of the miner? Talking about the immersion cooling system, comparing to the airflow classical. And the second is, are there any kind of open issue about immersion cooling system? Any major open issues?
I think we resolved, just to answer your second question, I think we resolved all the major issues. Of course, it can be fine polished and tuned and so on, but generally it's mass produced already, so we can deliver any amount of these containers pretty quickly. It just works. And the first question, I think I already answered. It's just much more stable, so lifetime of the mining equipment is only limited by the market. So efficiency of the chips is at certain level, and if new chip generation appears on the market, just makes sense to replace it to the more advanced unit. And except that, it just works.
Thank you.
Any more questions? Oh, one more, please.
Hopefully the last one before you get some deserved lunch break.
No, I like questions. So.
Good.
Thank you.
I was interested, obviously, the advantages to wind heating, or just generally cooling the ASICs with wind external and doing it this way, to your version. Remote areas, especially Africa, I guess a lot of stuff in South America would be very interested, I guess. How far would you see that coming first in Europe, and what would be the timeline to get it into more remote areas in the near future?
Yeah, Latin America is perfect because it's humid climate. It's not very good for air-cooled solution, but for this solution is perfect. And I think we will have very good showcase in one of the Latin American countries very soon. In Europe, still there is a limitation. Electricity price is very expensive, so we cannot get it from the grid. Land is, sometimes hard to get also to build renewable infrastructure. Potentially we can use hydro, but it makes more sense for hydro power plants just to sell currently electricity to the market. But like I mentioned, that additional features what we discovered with heat, energy stabilization, and creating small-scale renewable just makes sense, and I think it will expand this way first in European market for private or not very big customers, and large scale, of course, in a much better, much more suitable places in the world. So, like I mentioned before, our system allows to run very efficiently and very high ambient temperatures. So it opens up a huge market in Emirates, for example, in Kuwait, all of these countries, where we generally have no competition. So no miners can run any equipment there due to very high temperatures. And once we will have good opportunity to run showcase or mining farm there, of course, we will use it.